Here, Bill, since 1996, performing professional stucco inspections, mold, and other indoor air quality assessments. So give a hand to Bill as he comes, please.
If he wants to put it on, just clip it on and click the top on top of it. It'll get through. Makes it easier to walk around.
Can you hear me?
Yes, sir.
Good?
Yep. Put the little thing in your pocket if you want to make it.
Oh, yeah. It doesn't give me much room to walk around if I leave it on the thing.
It doesn't.
I'm encouraged that people actually showed up this morning when they knew I was going to speak again. That people said, "To hell with this. I've got other things to do on Saturday in Wisconsin." But I appreciate you coming. I think, Will, I've got to about 10:30. Is that correct?
Yeah.
Time? Okay. What I've done when I saw the agenda for today is I stripped the cladding systems down a little bit. You know, I'm assuming that you guys are all pretty well versed on vinyl and composition siding and hardy plank and all that sort of stuff, that you don't need me to talk about it, and maybe focus on the things that you may still have some questions about. And particularly with 10 new people here, this might be your first opportunity to get some of this information when you're going out doing home inspections, to understand some red flags that you might be aware of when you're on the property that you may have not looked at in the past. Before I start, I just wanted to let folks know that I've actually sold the business, All American Home Services, to Mill Creek Environmental. They'll be taken over. They'll still operate as All American Home Services. All my same inspectors will be working with them, so the quality of what goes out will be exactly the same, except they have, frankly, the resources and the patience at this point, I guess you would say, to take it to bigger levels. So my role with them, once we complete the transition, will be acquiring more qualified inspectors, training them, continuing education for the inspectors that are working with them to maintain the level of what we've been doing over the years. So I do appreciate the interaction with all you guys. I know a number of you have sent people to us for stucco and mold inspections when you run into those situations. And I would hope that you do the same going forward with the new group, because you're going to get the same thing you've been getting in the past. So I do appreciate you allow me to come to these meetings over the years. What I'd like to do at this point, I'm going to focus on really two types of cladding systems that you don't run into as often as you do the other types. And let's see if I can work this thing. It's going to be stucco and stone. And I know I've talked about these things in the past, but what I've done is I've fleshed it out a little more today than what you may have heard in the past, give you a little more details and data on it. Again, for you new folks, these things you're going to run into when you're doing a standard home inspection. You need to understand what you're talking about when you're advising your client as to whether you think there's a problem and they should get, just as you would refer someone to an HVAC contractor to do something that you suspect is a problem. You might do the same with the stucco, or if you find fungal growth in a home that you don't deal with, refer them to a qualified environmental professional, which we think All American Home Services is, but I do appreciate what you guys have done that, and I would encourage the new folks to plug into that to keep yourself giving the proper information to your clients as you're doing these inspections. It'd be good if I didn't press the pointer thing. There we go. In the types of stucco, you've got really two categories. One being hard coat stucco, which is your traditional Portland cement-based stucco that's on homes. It's really what's considered to be a water management system, in that it accepts the fact that moisture gets behind cladding systems throughout their lifestyle. So it has facilities such as moisture barriers, weep screeds. Obviously they all require flashings and sealants, but it allows for the fact that when moisture gets behind it, it allows it to get out to atmosphere at a termination. Whereas your synthetics, which is commonly referred to as EIFS, exterior insulation and finish system, that's the synthetic stucco that all the class action lawsuits were around in the late 90s. Everybody was getting their butt sued off, and in most cases, rightfully so. You know, the product was defective to begin with, and that it didn't allow for the fact that moisture would get behind it. Then you had people not installing it properly, and that kind of compounded the problem, where it was allowing it to get in and then it couldn't get out. So we're going to break those down. Each of them has their own items, but there's a lot of commonality between the two categories that apply in both cases.
Excuse me.
Yes?
Did you identify synthetic stucco as a defective product?
It is. Well, and I'll say that there's two types of that, but there's what's called barrier EIFS, which is what was originally out. It was banned in the state of Georgia April 1st, 1997 on residential wood frame construction. The reason for that is for what we've just talked about, is that when moisture got behind it, the facility was not there for it to get out. Its only way to move was to consume the building. So as it ate things, it continued to move down wherever it came in. It was ruled to be a defective product in the courts. That's why they were the class action suits in the early 2000s.
National class
Right,
action suit?
that's correct.
And they won just like any
Oh, yeah.
other society?
Absolutely, yeah. And all of that, I was one of the certified inspectors for the class action suit. And it was for that reason, is that it was defective in that it did not provide the facility for moisture to get out. You have it with all your other claddings. You even vinyl and aluminum siding have little weep holes along the bottom of the panel. It did not have that. So it was ruled defective in the courts, class action suit. A lot of people got repairs made and all that to their homes based on what was going on from the inspections that were conducted. In '98, what they did is they came out with a drainable version, which had an insulator board with grooves behind it to allow moisture to theoretically run down to a termination, and then they had weep screeds at the bottom and other terminations so that that moisture could get out. I'll tell you a quick funny story, which I don't know what happened there, is I did a lot of litigation work as an expert witness, and I was in Myrtle Beach, South Carolina on a stucco complaint. I pulled in the driveway and said, this looks like a drainable system, the way it was put on. But the people were having tremendous amounts of moisture showing up at windows. So I said, what the hell's going on here? So I was doing my investigations, I probed, sure enough, high moisture. So as part of the litigation, I had to gather evidence in the case. So I would cut holes in the house to document each layer as you go through as to what was there. And the key word that I just said before with the drainable systems, it has grooved insulator boards that I'm sure all of you can understand that they'd have to be running vertically for the water to go down to the termination. Well, these guys decided it was too much trouble to notch it around the window like they're supposed to. So where the normal panels were going this way, they took them and did this under the window. So guess why the water was eating up the house? Okay. So until you can remove humans from the process, you're going to have that stuff go on. But that's where they must have had a couple of beers at the end of the day, saying, wait till those poor devils see what's going to happen to their house based on what we did today. Good pointer again. Okay, and a hard coat stucco. All of the hard coats, and we're going to kind of talk about the various versions of them in a minute, but they all have to have a weep screed, which is a perforated channel at the bottom of the system, and that's for that ability for moisture to get out when it reaches the bottom. It has to be by code, and you guys will find this now in your IRCs. It never used to be before the, I think, 2006 version. You had to go to ASTM standards 926 and 1063 to find out the requirements for installations of control joints and weep screeds and all the rest of that stuff. Now it's in the exterior cladding section of your code manuals if you want to bone up on this stuff a little bit. But it has to be at least 4 inches above finished grade, which all you guys understand anyway, that cladding systems are not supposed to go below ground. They're supposed to be 6 inches above grade anyway, right? So the weep screed has to be a minimum of 4 inches above grade, but no more than 1 inch below the sill plate of the house. So when you take that into account with what you guys already know about codes and all that, it fits perfectly into how things ought to be. Stucco cladding should not go below ground, period. The other part with a hard coat stucco is because it's Portland cement, it will wick moisture from the soil up to the sill plate of the house. Unlike the synthetics, which the insulator board will just float in a bucket of water, they won't wick the water, the Portland cement systems will. So even not from a termite issue, but also from a water issue, you don't want to have hard coat stucco going below ground. The other thing that a hard coat stucco system has to have is horizontal and vertical control joints. And many of you will see the horizontal line at floor lines in a stucco cladding. But there's also required to be vertical ones that run from the horizontal joint to the corners of windows and doors, because that's where the stresses of the house moving will focus is at the corners of penetrations. So those control joints are supposed to be there to pick up the movement in the system. The other thing is if you have a large wall area, it has to be no greater than 144 square feet. Just as your driveway is broken up into sections, it's for that ability for the system to move without finding a place to break, is the accounting for that.
Question real quick?
Sure.
I've never seen them.
You are absolutely correct.
Never.
Absolutely.
So we should be calling that out on every house.
At every stucco house, hard coat stucco, not EIFS now,
Right.
hard coat, it has to be not above, not below ground, although they'll think of it, the realtor will, it's a termite issue, and we've got a termite bond, which is wonderful, but it's going to wick moisture up from the soil. So absolutely, there should be a weep screed at the bottom of the hard coat stucco system, period.
They can cut that in after.
They'll cut it in, or there's another way to do it where they'll actually drill weep holes right at the top of the foundation level around it, where they'll slant upward a little bit. So that again, it provides, just like with brick, where you have weep holes, at least for it to have an opportunity to get out the atmosphere. That may be a more practical way from a cost standpoint versus trying to cut hard coat up. Because hard coat is, I think, around $18 a linear foot to cut up above ground.
So was that just the common install method back?
Sure, nobody follows instructions. That's too much trouble. I mean, you guys know that. You're on these houses every day. You know, if they all did their job perfectly, you wouldn't have it, you'd be doing something else for a living, right? It's the same thing with this. It's whatever's easy or whatever daddy told them to do or whatever. Yep.
If the bottom of a hard coat stucco is not sealed, what's the difference in it just being open at the bottom versus having a weep screed in it?
Well, if it's just open at the bottom and it's above ground, then that serves the same purpose. But remember where the weep screen's supposed to be is no more than 1 inch below the sill plate. So if it's a foot down the foundation, remember all that Portland cement and lath and all is adhered to the concrete, right? So to a degree, it would probably get out at some point, but it's still not operating the same way as far as that. But it would solve the problem of it wicking moisture from the soil, for sure. The other thing is it's got metal lath. One of the things I've found in my litigation work, and this will be something if you're looking at the exterior of a stucco house and you see the horizontal control joint, but you see cracks running through it, like from above it to below it. What that indicates is that they didn't install the metal lath and the control joints properly. What's supposed to happen is they put their weather barrier, whether it be felt or house wrap, over the sheathing, and then they put the control joints on to create all their grids. Then they're supposed to attach the wire, a metal lath, to those control joints so that they have the opportunity to move. What a lot of guys do is they put the felt paper on and then they put the metal lath on the whole wall and then tack the control joints over the top of the metal lath. So it can't move. It has no ability to flex with the control joint. So it begins to crack through the control joint as the indicator that that's what they did in that situation. And again, I found that when I'm cutting holes, I can see that they did that. The other thing is, and it's really the same thing with synthetics, that there's supposed to be a 1/4 inch gap left between the side of what's called the casing bead, which is like J channel, the vinyl siding where it edges out the window or door. There's supposed to be a 1/4 inch gap left between that casing bead and the side of the window or door frame. Then that's filled with a backer rod, which is a polyethylene non-stick surface, and then the sealant is applied over that so it has the ability to move. You see it all the time. It's right up against the side of the window. The day they put the stucco on, they run the stucco finish up against it. Everything looks wonderful. And in about a week, when it begins to cure, everything pulls back. So they have all these wonderful gaps around the windows and doors where it's an opportunity for moisture to get in. Yes?
Late 80s synthetic stucco, nailed straight to the studs.
That's right. Well, only some can. See, when they, and we're going to get into that in the EIFS section, but what many folks refer to as a Celotex board, it's actually called polyisocyanurate. When it's used in an EIFS application, and it's 1 inch thick, it can be attached to the framing itself, and then the finish coat will apply to it. However, there has to be a weather barrier between the board and the framing. Okay, that's a requirement by the manufacturer when it's used in an EIFS application. It's never there, you know, just as, it's never a weep screed, you know, all the rest of this stuff. But that board can be attached to the framing over a weather barrier without a sheathing on the house. But all your EPS,
No weather barrier.
right, there has to be the weather barrier behind the polyiso. Say it again. Yes? I thought I just saw a hand up.
Let me ask,
Oh,
a lot of the older, real hard coat stucco houses do go below grade, and particularly some larger gated communities. Should we be putting in our reports to correct that to this standard?
you can do that, or it's likely indicative, and what you're going to see is some other red flags that when you're doing your standard inspection, if you don't do a full-blown stucco inspection with moisture testing, then you really don't know all the implications of what's happened to that home besides just the fact that it's below ground. That's where a number of guys here say, look, I don't do these, call All American, have them come in and do a full-blown stucco inspection, because we do moisture testing. We write the scope of work as to how things are to be corrected, with the diagrams and all that, so that if they're going to have anything done, at least it's done properly. That's the main perspective of it. But you're going to see that there's other red flags when you see stucco on a home besides just the fact it's below ground. But they do that because it looks better, right? It goes below ground, it looks nice, all the rest of that good stuff. But we're into performance rather than aesthetics in general. So that's the reason for that. The 1/4 inch gap, and then the gap is filled with baccarat and sealant, and then there's obviously a moisture barrier behind the hard coat stucco that can be felt through a house wrap. Now, what you'll get, and you guys know this also, is that a lot of times in houses, they'll have a structural sheathing on the corners like plywood or OSB, but they'll use insulator board on the field studs. They do that even on brick applications. So what happens, you got two issues. One is when they staple or nail the metal lath, what's holding up most of all that weight is 1/2 inch extruded polystyrene, right? Your blue board or green board, that's holding all that weight. So you wonder why you get cracking. The other part is the builders will say, well, that's a moisture barrier because water can't go through the panel. The problem is, in order for that to be true, they have to either tape all the seams or it has to be a tongue and groove insulator board, which they're not going to do. But you never find taped seams. So what happens, the moisture gets in here and runs down the insulator board and then goes in at all the seams. So it becomes much more difficult to find out where the water is affecting the house versus where it came in, because it moves and then comes in rather than going in at the point of entry. So you're going to find out a lot where there's insulator board behind the hard coat stucco as the substrate of the house. So it's not only an issue with holding the weight that's on it, but also the fact that when the seams aren't taped, the moisture is going to have an opportunity to gain access all over the place. That's why some folks think that, well, it's hard coat, doesn't need to be inspected. Not true. I've got a lot of hard coat clients in litigation. It experiences a lot of the same problems. It just sometimes takes longer to manifest itself. But they occur all the same problems when things aren't done right. Sooner or later, the water's going to affect their house. Matter of fact, in Carolina, I did a house for the son of one of the prominent senators there a long time ago. And when I did it, I found the structural bands were rotted out of the house. And it was a 12-year-old home. Now, in Carolina at the time, the statute of limitations was 13 years, which is why I was able to be brought in. The statutes hadn't run out like they would have in Georgia, for instance. But all of a sudden, when you can take a probe and push it into the structural bands, that's the effect of water reaching the bottom and having nowhere to go. And all it does then is it starts to go inward. It starts to overwhelm all the framing of the house. So what seems like not a big deal, incidental moisture over a long period of time will kind of do a number on it. I keep pushing that pointer thing. Okay. Within hard coat, you have a traditional hard coat stucco, which is 3 coats, which is a scratch coat, then a brown, and then a finish coat. Most times the finish coat that you'll see even on a hard coat stucco is actually a synthetic stucco finish. It's a much smoother finish coat, has some aggregate markings in it, but it's not that very old style rough finish to it. But it's the same coating that's put on a synthetic at the end. The thing that they cannot do by instructions is install that when it's below 40 degrees because of its effect on the curing of the moisture that's part of the Portland cement mixture. Now what some guys will do is they'll put antifreeze in it, saying, well, that solves that problem. Well, not quite. Then the other part is they have to allow 24 hours between coats to cure. But that assumes that they didn't get rain, overnight or something like that. But they, as you know, everybody's in a hurry to build these things, and they're putting it on as fast as they can put their hand on, say, oh, it feels pretty dry, we'll put the next coat on. And then you start getting problems with spalling, and it starts flaking apart. Yes?
Can I go back 1 second to the, we were talking earlier about the application, and you said that it's required to go over a sheeting. I remember at one time I was looking in the code book trying to identify exactly how it illustrates that hard coat stucco is applied.
Yeah.
And basically it said, if I can remember correctly, it just said a weather barrier, which could be felt paper
Or house wrap, yeah.
or house wrap, and then it starts applying the lath and having it nailed off to the structural and coming forward. So it really never said that it had to have a rigid sheathing behind it.
Yeah, well, you do have to have it on corners by code. Yep,
From
code
the
requires
structural
structural sheathing on corners.
Yes.
But you're right, the hard coat can be installed over open framing, unlike the EIFS. But then they're usually using furring strips to attach to
But
that.
it doesn't identify that in the code, does it? I mean, it doesn't.
No, it's, yeah, you can use open framing, but you still by code, regardless of the cladding system, have to have structural sheathing on corners. Right?
Yes, I guess what I'm trying to get at is, in the field,
Yeah.
if you just had
Fields.
half-inch styrofoam sheeting put on there.
Right.
So it's not really structural, right?
That's right.
Then the lath, the process starts from a vapor barrier coming on top of that sheeting,
They don't do that, not on the insulator board.
but you have to take the joints.
You have to take the joints, or it has to be tongue and groove, so that it actually does serve as a moisture barrier, the insulator board.
Okay, so if you have the styrofoam sheeting, then it needs to be tongue and groove or tape joints.
Right.
And then that would be considered the vapor barrier.
The moisture barrier.
Moisture barrier,
Right.
and then the lath is applied to the.
That's correct.
To the frame.
But that's correct from a moisture standpoint, but remember, they're nailing or stapling the metal bath every 6 inches on center, right? So the only places where it's hitting a stud is at every 16 or 24 inches. All the ones in between the studs is into insulator board. So all that Portland cement that's being applied to the metal bath, most of it is being supported by insulator board.
I guess I'm confused.
Okay?
So the metal lath has got to be secured every 6 inches, is that
Right,
what you said?
on center, that's right.
And that's specified in the code.
That's right, and you look it up in your IRC. It used to be in those 2 ASTM standards as to how it was to be fastened. But what you're getting then is most of the fasteners between studs are into insulator board in that application. Although the insulator board qualifies as a moisture barrier if the seams are taped or if it's a tongue and groove. Then you have the next problem of, by doing that, without structural sheeting on the whole wall, you have all that weight being supported by something that's not very rigid.
So then if you see or find a home, I mean, if you're up in an attic, and you're able to look at the gable end, and you
Right.
see that you just have that there's no lath,
Right, you're gonna see the backside of the insulator board.
okay? But
And-
if you remove the insulator board and all you see is felt paper, and you see.
You're not gonna
lath,
see that. They're not gonna put felt paper over the insulator board, I'll tell you that right now. What you're gonna see is where the two insulator boards come together, there's gonna be a space, and you're gonna see the Portland cement oozing through the two panels. There's not gonna be a moisture barrier on top of the insulator board. They're going to consider that the moisture barrier, as well as the field sheathing of the application.
So you see a bunch of staples coming through.
That's right, you watch, you'll see them all coming through.
Then that's instantaneously, you know that it's installed incorrectly.
Well, not that it's, the only thing incorrect, they're allowed to use the insulator board, but I'm just thought conceptually, imagine what's happening. They're allowed to use the insulator board just as they could apply it to open framing, right?
But you're not supporting the wire lath.
Well, that's right, it's not being supported as soundly as it would be if it were a plywood or OSB substrate on the whole house. Because most of the fasteners, which you'll see coming through the insulator board, that's all that's holding up the stucco in that application. And it doesn't say they can't do that. They deal with it from a moisture barrier standpoint in the instructions that that's to be tongue and groove or taped, right? So that then the insulator board, yeah, the water's not going to come through the board itself. But the other part of your problem is why you get a lot of cracking in stucco, hard coat stucco applications is because of that movement, that what it's attached to isn't rigid. It's flexible. And it's not designed to flex, hard coat. It's like your driveway is not designed to move. So then what happens is it starts to break. Then if you don't have the control joints at all the places it's supposed to be, it starts finding its own points of weakness and cracking. And you'll see the pictures of where they most commonly occur. Yes?
What I'm understanding is, does the code not say how hard coat stucco should be attached?
It talks about how the lath is to be attached to the substrate. In other words, 6 inches on center. It also talks
It
about...
doesn't say it's substrate, what it should be
No, it doesn't, because it can be installed over open framing
with that, with the locks.
with furring strips. So it's not the sheathing itself, except conceptually, when you think about it, the insulator board is holding up all that weight. So you tend to get more cracking in a hard coat stucco when it does not have a rigid substrate than when it's using an insulator board. And you'll note, when you see the houses, when you see it in the attic, then when you walk around the house, note how much cracking is going on in that system.
No, I mean, what you're saying, I understand, that was my frustration. I still kind of feel it. Is that I couldn't find the answer. You know, I mean, the code says it can be attached to the framing and have the studs.
Right.
The lath can be attached to the studs.
Yeah.
And then if you, and I don't remember seeing the part where it says that it can be, it has to be, the lath has to be nailed off
Yeah.
every,
And that's the reason for the furring strips.
but it doesn't say that.
Well, when you, I'll give you a little, go to the Portland Cement Association and the American Concrete Institute. They have good diagrams of how that's done. And they'll show you the diagrams on a rigid sheathing versus open framing where they use furring strips over the moisture barrier that's attached to the studs. But like we talked about, there still has to be something to attach the lath to, right? You're not going to attach the lath to felt paper.
I would think that, yes.
So, yes, you don't have to necessarily sheathe the whole house, if you were thinking of cost as a builder. But, and you say, okay, well, I'll put my felt or my house wrap over the studs, then I'll run my furring strips, right? Then I attach my metal lath to that. So now you have something rigid that you're stapling or nailing into, correct? The wood furring strips. But that's not what they're doing. They're putting structural sheathing on the corners, hopefully. And sometimes we find they don't even do that. And then they're putting 1/2-inch extruded polystyrene, which is your pink, green, blue, yellow board, as your field sheathing. And then they're nailing this heavy-ass stucco to it. And it doesn't respond well to that. There's too much movement, which causes, and when there aren't control joints, it just says, I figure I'll break here, this looks like a good weak spot, I'll break there, etc. I think he was first, I think. Yep.
Yeah, so you're saying that it's legal by code to do it that way, and it's okay from manufacturer specifications to install it that
Yeah.
way, but it doesn't make any sense.
Yeah, you know, a lot of stuff we do, there's a technical answer, and then there's, you know, all right, what do you think type of thing. And when you do this every day, you see the ramifications of common practices.
So you're not gonna find any code or anything to help you write something like that up?
No, other than that could be that's, again, why I think maybe there's another reason to send them to a qualified stucco inspector. But the thing is, you can say, not that it's wrong, but you've got a lot of cracking that may be due to this application, right? But there is also the thing, when you go up in the attic and you see 2 pieces of insulator board with a space between them, and the stucco and the lath are visible, then they did not take that seam, obviously, right? And it's certainly not a tunneling. That is an error, because that's a requirement when they use the insulator board as a substrate. It has to be one of those 2 things for it to act as a moisture barrier, because there will not be felt paper or house wrap over the insulator board. It'll only be over the plywood or OSB on the corners that come over the insulator board a little bit, but on all those open panels, that's not how it's going to be. Okay.
So basically, we know that hardly ever you're going to find a direct installation.
Correct. Absolutely correct.
In your experience, how many percentage-wise would you say hard coat stucco actually causes damage?
Good question. Like I said, I've done hundreds of litigations. And I do hard coat, EIFS, brick, you know. And I had a house, and it was not in Myrtle Beach, but one of the towns over there, where it was a hard coat stucco. And I probed it, everything was wet behind it, soft framing when I went in, right? So I said, what likely happened, because the sealants weren't good, but I said, the other thing that goes on, and you guys know this when you're doing your pre-drywall inspections, you see the framed opening where a window's been put in, and they run the house wrap into it, right? How many of you have ever done wallpaper in your lives, in your home? When you're going around the corner of a door, what do? You cut a slit, right? And then it fits around it. How many times do you see that being done on the framed opening for a window in the house? Where the wood is exposed on the corner, where all they did was slit the house wrap to go around that corner. Well, where do you think those windows are going to leak when they open up at the joints? Exactly where there's no protection. That's why in the stucco applications, and particularly EIFS, we're going to get to it in a little bit, but there's required to be what's called a sill pan flashing, which in essence is a metal pan with edges on it and a flashing edge that sticks out that the window's supposed to sit in. So that when those joints open up, even though they're sealed when they leave the factory, it bounces around in the truck, then the guys unloading it are bouncing it around as they walk over, then the guy putting it in is banging it around. And then over time, obviously, things will open up, that the seams at the corners of the sill and the jamb will open up. And then the water gains access to the framing beneath, and there isn't any protection in those locations because of the way they're cutting the moisture barrier to go around those framed openings. So all the little things on their own that don't seem like a big deal add up over time as far as protecting the home against moisture over time. And then all of a sudden, some fool like me shows up and starts finding all these problems. Everybody goes, holy Christ, how did this happen? You know, well, it all started in the beginning. They didn't seal anything. They didn't put flashings in. They didn't put kick-out flashings. The substrate, you know, why we have all this cracking going on, it's all part of all those things working together against the house.
Is this not the same guidelines that homeowner would find in EMA, in the EMA inspection?
EMA is only for EIFS applications, has nothing to do with hard coat, because it's the Exterior Insulation Manufacturers Association. So, and the things we'll talk about when we get to EIFS would be in your EMA guidelines, that's correct. Okay, we got to the traditional 3-coat, which is your old style of doing it. Then you've got what's called a 1 or 2-coat hard coat stucco system. And what it is instead of somebody on site mixing the Portland cement with sand and water to create the mixture, it comes already pre-mixed in buckets. So then what they're doing is they're doing their same, you know, substrate, weather barrier, metal lath, but then they're just taking it out of the bucket and troweling it on, letting it cure, and then putting a finish coat over that, which is essentially the same coating as they use on an EIFS application, so it has a relatively smooth surface to it. It's still a hard coat stucco system. Has the same requirements for weep screeds and casing beads and control joints and everything else because it's still going to flex. But it's just easier for them to put on and doesn't take quite as much time as mixing on site. So in theory, there's more of a consistency to how the mixture is when it's coming from the factory that way. Did I split that bit? Then there's another one that we've run into a lot lately, which is called a skip trowel hard coat application. And that's where you see that very rough finish. And if you ever look behind it, if it breaks or if there's an opening, you'll see it's almost like chicken wire. It's not your diamond wire lath like you see in a traditional hard coat. And generally, you're going to see a 1/2-inch EPS, or your white insulator board, as the substrate. So the insulator board is attached to the framing. They smear a mortar base coat on and put the chicken wire in it, and then they put the finish coat on and give it a little twirl as they're doing their trowel to give it that unique look. These things break like eggshells because there's nothing to them. A 1/2-inch EPS is nothing. The extruded polystyrene is a much more rigid insulator board than the expanded polystyrene is, which is your white coffee cup material. So these things are, so again, you got the 1/2-inch EPS is installed, you got the chicken wire, it's not your standard metal lath like you'd expect to see. It generally is rusted if you get a chance to look at it, because it's generally not galvanized like the diamond metal lath is. And then your Portland cement finish with the rough finish. A lot of folks think this is an EIFS application because when they maybe take an electrical cover off or something like that, they see the EPS there. And there generally is some fiberglass mesh mixed into this mixture that they're putting over the chicken wire to give it a little more strength and flexibility. So some guys will see the fibers and say it's an EIFS application because we've got insulator board, the white insulator board, and then we've got a little bit of fiber sticking out. But it's not. A skip trowel technique is not allowed to be used in an EIFS application. It's only a hard coat, therefore has all the same requirements for weep screeds, control joints, the whole shooting match, because that thing's going to move just like the other hard coats will. So this is something that you may run into, especially when you're just trying to understand, is there a problem with this house maybe where they need to have someone else look at it. When you see that, that's generally a hybrid type of hard coat stucco where it's called a skip trowel, which is the technique that's used when you're applying that coating on the end to give it kind of a unique, almost a seashell look when you're looking at it.
Anytime we see wire mesh, we can say it's.
Oh yeah, it's a hard coat, then it's just a different form of it, yeah. But some guys, when they see a little bit of the fiberglass fibers and then they see the white insulator board, they assume EIFS. Not the case. Okay. Generally, when an insulator board is used in a hard coat application, it's an extruded polystyrene, your blue board, green board type, which is a half-inch thick, but it's much firmer than is your EPS of the same thickness.
And skip trowel finish is the Portland cement thickness still?
It's the technique that they use on the end. Instead of running it smoothly like they do on a standard hard coat, they'll actually flick. So that's why it's called a skip trowel.
But isn't there a minimum thickness for the Portland cement application?
It's not a half-inch thick. It
So
is.
skip trowel is still half-inch thick?
Right, yeah. And hard coat could be thicker than a half-inch, but it's got to be at least a half. Because your EIFS application will go up to 3/8. Once you get into that half-inch thickness, it would lose its flexibility from an EIFS standpoint, its ability to move, which it will. So once you get into the thicker coatings, then you're getting into your hard coats where they're much more rigid. But just, it's not an EIFS application, so you should understand that when you're going in. Okay, this is your skip trowel look, where it has, I'll try to get it away with it here. You see that rough finish like that? That's the technique that they use with their trowel. I'll try to get it your way there. But I know we were filming this, I'd have lost some weight before I came down today. And then you can see, here's your chicken wire here versus your standard lath, all rusted. It breaks apart the stuff, because what happens is it starts to spall. And then it actually begins to just break off the finish because of the way it's put on, and it's on that insulator board. And you'll see it's all rusted lath or chicken wire. The cement itself is just coming apart on these houses.
Should we be worried when we see a skip trowel application in general, or?
Well, yeah, and that it seemed like a good idea at the time. You've heard that in other things, but it really doesn't work very well. Every one of them we do, and Charles and them will tell you, they're disasters when you go in there. There's a tremendous amount of damage that happens to these homes. A lot of bulging on them, a lot of severe cracking, where it's just breaking apart, all those sorts of things. So they tend to become fairly fragile as compared to a conventional hard coat, which will stand up to impact and all more.
Well, based on the age, we could hopefully see evidence that there's been a problem, or there's a problem.
Yeah, you're going to see that for sure. Okay, now we'll get into our EIFS stuff, and as we talked about, barrier EIFS was banned April 1st, 1997 by code. Can't do it. We do inspections in South Georgia. You got EIFS applications going up just the way it was then. The word must not have gotten down there. Okay. So they're putting it on down there, it doesn't matter. It's whatever they still had in the garage, I guess. Okay. And you have two types of that. There's class PB, which stands for polymer based, which is a much more flexible system. It assumes there's a lot of movement to an EIFS application because the bulk of the thickness of the system is the insulator board. It's only about an eighth of an inch thick coating on that. So most of the thickness that you see, which is 3/4 to 1 inch in most cases, is all insulator board. So that sucker is expanding and contracting like crazy. So the polymer base, which is primarily what you saw in your barrier EIFS, was designed to pick up a lot of that flexibility. So there's a lot of polymers mixed into the finish coats or base coats. The other type is, and within Class PB, you have your barrier systems, which were banned. Then you have your drainable system, which nobody's using anymore because they oversued. So they're not touching this stuff at all on residential structures. They said, we've had enough, we don't care what you call it. But you'll still see a lot of it on commercial applications. One of the reasons for that is it's primarily concrete and metal framing, so it's not as big an issue. But the size of the job, there's enough money in it to justify a technician on site to make sure things are done right. There isn't enough money in an individual home to justify that. So you don't have anybody standing there watching what the guys are doing saying, no, you got to do this. That's not happening on the residential side like it might be in the commercial side. The other one is Class PM, which is polymer modified, which it's almost like a hard coat stucco system in that it's much more rigid, and it generally incorporates your XEPS or extruded polystyrene. It's really designed for high impact areas, such as like on a commercial building where people walk by a lot, to provide impact resistance. It also uses a much thicker fiberglass mesh, which is called a Panzer mesh. It's 2 to 3 times thicker than the standard fiberglass mesh that's used in an EIFS application. And again, it's for that purpose, which it'll stand up to people bumping against it or what have you and not break. Like standard EIFS houses, you see all these little marks like people that were hitting golf balls in their backyard, and you get all these dimples all over the place. It's very soft, easy to break through. The PM is a much harder surface, although it's not a hard coat stucco. Yes?
On both types of siding, corrections are sometimes advertised in the paper of using this vinyl coat or some sort of rubber or polymer coating, and I've heard that just 2 applications basically takes vapor transmission out of the material. Could you comment on that product and your experience with it?
I have to send you a check now because you've done what I put you back here to do, which is ask this question. But I won't comment on the product. I will tell you this, is you cannot, sometimes mama wants a different color on the house, and it's an EIFS home. You can use conventional house paint, but then you're in a maintenance cycle, which you would not have to normally be with EIFS because the colors are pigmented into the finish. You cannot put any sort of a barrier like those coatings or even an elastomeric paint, which is used in coastal regions a lot because of the severe weather. Because it does that exactly, it creates a vapor barrier on the outside of the skin. And then the EIFS application itself is a vapor barrier. And to his point, what happens then is you interrupt the moisture vapor transfer, which is when it's hot and humid outside, the hot, humid air attempts to come through the walls to the cool, dry side, which is the way nature normally moves, high pressure to low pressure, right? What it does, it changes the dew point so that now instead of the 2 temperatures meeting on the outside of the home, it actually occurs in the wall cavity. And this is how I got in the mold business many years ago, is when I was cutting holes in houses, gathering evidence on stucco cases. I was running into mold in the walls from not only the high amounts of water getting in, but where they'd have that condition, or they'd have vinyl wallpaper on the interior of the drywall. The vinyl wallpaper is a vapor barrier too. So where they put that up in kitchens and bathrooms, I would find mold in the walls of those cavities when I would cut into them because of that moisture vapor transfer situation that's causing condensation to form in the wall cavity and then breeding mold on all the materials. So to your point, you cannot put any of those coatings on an EIFS application. You can do it on hard coat, but EIFS, because it's a vapor barrier in itself, cannot have a second vapor barrier involved in the process, whether it's on the outside as a coating or even vinyl wallpaper on the interior walls.
So there's no limit on the number of coats you could put on a hard coat?
Right, yeah, basically. Yeah. Because it in itself is a porous material. EIFS is not. Okay, that's the difference. Is the hard coat stucco, just like putting multiple coats of paint on composition siding. Same concept. The composition siding is not acting as a vapor barrier itself. So many, you paint it every number of years. Right?
So the moisture barrier is what's really doing it.
It's the vapor barrier, right? Yeah. But great question, okay? Because that's important, and people never think of that stuff as what's happening with moisture. It doesn't have to be pure water coming into a house, it can be in the form of vapor as well, and it interrupts the normal transfer, and then it comes to the interior of the home, then your HVAC system removes it and pumps it out the condensate line, right? That's the kind of cycle that you're in. Once man starts getting involved in that cycle, we screw everything up, right? So, good question. So the Class PM is, and you see very little of it, but when you do see it, it's primarily on a commercial application where you got a lot of traffic, people walking by, banging into it, and they don't want to have all these dings all over the place.
What's most common for residential?
Oh, it's absolutely barrier PV. Like I said, all of that stuff was put on into the mid-90s before it was banned. Some of it even a little later because the CO maybe had been issued earlier and they didn't finish it till 98 or something like that. And like I say, you go down in the South, Joe, they go, codes? What codes, This is the stuff we've been putting on for years. But once everybody got their butt suit off, they all stopped using EIFS completely on, you primarily find the hard codes, but they're taking the same care to install it to the instructions as they did with the EIFS. Okay. So, see, you got the joke there. Because we're paying attention to details, okay? All right, barrier EIFS. There is no moisture barrier involved in an EIFS application. That was the fundamental flaw in the court, is that there was, all of the cladding systems incorporate moisture barriers behind them because they understand that moisture is going to get behind it. There's no moisture barrier as part of the installation by design of an EIFS application. It's considered to be a barrier system. It assumes moisture will never get behind our product. The other thing is it's to be installed over 3 types of substrate, OSB, plywood, or gypsum board, hopefully exterior grade gypsum. And I say hopefully because it's not always the case. Then the other thing again, but to his point, is the polyisocyanurate board, which you may think of as Celotex board, is that gold or brown board. If you put it in a pail, it just floats. They can install that over open framing without a substrate as long as they have a moisture barrier between the board and the framing itself. And then all they do is just apply the EIFS finish over it. That stuff is literally like an eggshell. If you bang on that at all, you will go right through it. But pretty easy, they call it Quick R, actually is the product name. And it's for that reason, it's quick. We don't have to go through all that trouble of installing multiple layers. We can just pack it up and go and move on to the next house. So it looks the same, but very fragile stuff. And there's never a moisture barrier behind it. I can tell you that. You cut through, you're going right into the interior walls. There's the polyisocyanate. It's typically an EPS board, expanded polystyrene, which is your white coffee cup material. Now, we talk about the negatives of EIFS, but there is one positive, which is its insulating capabilities. Think of your cup of coffee that's very thin, but it doesn't burn your hand with the hot coffee in it. Well, now you make that 3/4 or an inch thick, and its ability to insulate the home is great. And you'll find that an EIFS home may have half the cost of energy as a brick home would be for that reason. But God help you if water gets behind it, which it's going to. So there's a positive to it. It also is the architectural ability. They can create shapes and all kinds of design things with EIFS because they can just cut it with a razor knife. So, no, I mean, it's true. I mean, so it's easy to create architectural looks that you may not be able to get with other claddings. Its insulating capability is very good. But man, is it a problem when moisture gets behind it. Because then the moisture can't get out. So it has nothing else to do but start eating the house. And that's what it does. It starts at the top and just keeps working its way down. The other thing when they're putting the insulator board on is there's always an opening, obviously. Nothing fits together perfectly. They're supposed to fill those gaps between the boards with slivers of the insulator board. And if any of you ever look at an EIFS home, and you can actually see the outline of the panels. They come in a 2x4 panel, the insulator board. Well, that's because they didn't fill the gaps between the boards. So what you're doing is getting, instead of a vapor transfer, you're getting a thermal transfer, which is reflecting itself in a grid look on the side of the house where all the inside and outside air are meeting between the panels. that weren't filled with the slivers of insulator board. So you get that wonderful checkerboard look to your home, which is what you paid for. And it can be polyisocyanated, but it has to be 1 inch thick. If it's going to be used without sheathing, the poly board must be 1 inch thick so it's rigid enough. If they put it on over a sheathing like gypsum or OSB, then it could be 3/4 inch, just like the EPS. Then they apply a cementitious bait coat over the insulator boards that are filled with the slivers. And then they embed a fiberglass mesh in the base coat, and then they apply the finish coat for the aesthetic look. The color is pigmented into the finish coat, and all they're doing is troweling it on. It comes in a bucket, all pre-mixed. And what you'll find a lot of times, some people try to identify what manufacturer it is. Each of the manufacturers have their own proprietary color fiberglass mesh to help them identify it. What you find though is the guy may have materials left over from the last house where he used fine stone, which is a red mesh. Then this house he's putting dry-bit on it because the architect may have called for that. But he's going to use up his supply of the old stuff first. So when I'd be cutting holes in the house, I'd be finding some spots with yellow, some spots with yellow or red, other ones with blue. So you really do not many times have one manufacturer. However, the installation instructions are essentially the same because the boards all expand and contract at a certain rate, so they have to account for that in their design. But you can't look at the color mesh and say, okay, this is a dry-bit system. Doesn't necessarily mean that. It just means there's some dry-bit on it in some areas. And then you have your synthetic stucco finish. The Class PM system, like I talked about, is a high impact area, primarily commercial, much firmer. There's fewer polymers in the base coat, so it's not as flexible. They use the Panzer mesh, which is much thicker, and then it's designed to prevent incidental damage, but you'll never run into that on a residential structure. It's going to be primarily on commercial and on the lower portions of it. Drainable eaves. This was the manufacturer's answer to all the lawsuits. Well, hell, we'll just put a grooved insulator board with a weep screed and a moisture barrier, and we're good to go. You know? But all the builders said, well, what the hell would I want to put that in my house after I almost just lost my entire life savings by getting sued by these people that I put your other product on their homes? So nobody does it. Like I said, I found one in Myrtle Beach, and they didn't install that properly. So at that point, you got to say, okay, let's go to something else at this point. But it's got the grooved insulator board and the weep screen. Any questions? Aha. Now we'll get into some pictures. For the ones, I think most of you have probably seen this part of the presentation before, but all your new folks, this will be important to you when you're walking around the house. These are the red flag type things that we talked about, that you're going to notice. You're going to say, we got a problem. You're going to see two types of situations at a window in this case, in that the one on the left, you can see there's remnants of where there used to be sealant at some point. But over time, the other part of the other half of the equation is the product's defective, it's not installed right, and then the homeowner moves in and puts the TV on and never does any maintenance on his home. So it kind of compounds the original problem. And that's what you're getting here, is where the homeowner has never had anybody come out and do any maintenance on that home because all the sealant has broken apart. The picture on the right, there's never been any sealant there. And then the homeowner didn't bother to walk around his house and notice that himself. So what you're getting is moisture entry at the windows and doors all around the framing of the window. I got that pointer thing. This is what it should look like. Again, when you're walking around a house, you ought to have a nicely tooled, not pulling apart bead of sealant around every penetration, windows, doors, hose bibs, electrical outlets, light fixtures. Any penetration through the cladding needs to be sealed this way. And you'll see it on both situations. You got it, and it looks good. It's not like it looks crappy.
What's it called, Dow?
It's Dow 795 is the one that's used most. However, a lot of the contractors, and there's one that I recommend because he has a good warranty program versus the scams that are out there. They'll use an MP1 product because it's paintable. See, the Dow 795 is a silicone sealant, so if the people come in and they have their windows painted, well, the painter may try and go over the sealant, but the paint's just going to slide right off of it. It won't adhere to it. So a lot of times when they know, when they have got wooden windows where they know there's a chance they're going to be repainted, they'll use an MP1, which looks the same when it's tooled on, but it is capable of holding paint from a maintenance standpoint. Then we get into your general penetrations. We just talked about that. You got your electrical box, your light fixtures. Never has been any sealant there. You know, no need to waste money putting sealant on things when you're building the house. But again, this is what it should look like. It looks good when it's done right. It's not like it's going to be an eyesore just because they sealed it. If you seal it the right way, it looks good, and then most importantly, it's protecting the home. Now, you obviously don't get large amounts of water getting in at a hose bib or a light fixture, but it's the concept over time. And again, I've had the luxury as part of the litigation work that I'd be hired on the back end to oversee the removal and replacement of the cladding on the house. So I got to see what happens when it comes off the home, what the home looks like behind the covers. And you'd be surprised that it ranges from staining to just stuff you pull apart with your hands at relatively minor penetrations where it goes on over a period of time. Or if it's on the side of the house, it gets more weather than another, more windblown rain, you know, those sorts of things. And it's unbelievable the amount of stuff that goes on in a home once you get to see what's going on under the covers.
Is it the same worry with hairline cracks over time?
Hairline cracks are not usually a concern from a moisture entry standpoint. When you get major ones where there's differential, you know, then that's got to be fixed. The hairline cracks really are not a moisture, they're more of an aesthetic issue. What you get though is that people will seal them. And you get almost as bad a look because the sealant looks like little squiggles all over the place versus the crack that you might not normally see. So it's really not a concern about moisture provided it's not differential or it's not a large crack. So from that, I usually write it up that way, that it's more aesthetic in nature. But cracking in general is an indicator of something not being done right, which we'll come back to with the control joint issue. When you see where the cracks typically occur, they're off the corners of windows and doors, which is exactly where the vertical control joint was supposed to be to prevent that. But the control joint's not there, so it makes its own break. It doesn't use a uniform place to break. And you'll see the pictures of that, which will be the common things that you'll see when you're walking around the stuff. This is one of my favorites. Roof terminations. You all know what kick-out flashings are? Does anybody not know what they are? Okay. Remember, it's got to go behind the roof wall flashing and under the roof shingles, right? And it's at the end where it diverts the water into the gutter, so it can't get behind the stucco at the transition of the roof to the vertical wall. The guys on the right must have been the same guys that installed the grooved insulator board horizontally, because they felt like that was okay to do that. Now, most guys, I don't know how high you guys go on ladders, but we go up, you know, we carry 28 footers and all that when we're doing the stucco inspection. We get up to places that you may not be able to see, you know, if you're doing a standard home inspection. And this is the stuff you find up high where they figure nobody's going to look. I had that happen where I did a mold assessment at a surgery center. It was a 2-story building. The front level was 1 story, and then it had a slope, and there was a 2-story rear to the building. They'd hired a company to come in and do maintenance on the outside, you know, sealing of windows and doors, etc. They did a great job of sealing all the windows on the first floor. But they had mold in the 2nd level kitchens and bathrooms that the people were concerned about. So when I got up on my pesky little ladder, they had touched nothing on the 2nd level of the home, because they figured nobody's going to see that when they're walking in from their car, right? Not a speck of sealant, I mean gaps like this, where the brick met the windows. So the water was pumping in the walls, and it started to manifest itself as mold on the interior drywall in the bathrooms and kitchens, which then they brought me in, and when I opened it up, you know, it was going on forever. So not only do you have products that may not be well thought out, but you have people that have crappy attitudes when they're doing the work, that they have no pride in what they're doing or any respect for the product that they're turning over to somebody. And it's whatever they can get away with. And it's not a good combination, you know, for the people that buy these buildings. And when you see that stuff, it takes away your faith in humanity. When you say, who the hell do I trust in this world that the guy wouldn't even do the 2nd floor that he was hired to do because he figured you wouldn't see it? You know, and that's why you were here, frankly. That's why people hire you, is to find those things for them. This is what it should look. This is called a dry fleck kickout. It's a pre-made plastic or vinyl kickout flesh, and they can make metal, you know, it's all fine. The big thing is that it's installed right and has a proper angle so that it throws the water into the gutter, doesn't let it get behind there. And also, with my trusty little pointer, this area here has to be sealed, which it is. So that, again, you don't get wind-blown rain gaining access behind it and getting in, although it's not the same as what's coming down the roof. Small amounts over a period of time will cause you a problem.
Is that a pretty easy fix?
Oh yeah, it costs about $100 for a guy to come in and put in that thing properly. But generally, it's not the only reason he's coming out. It's part of an overall job, and it's roughly about a $100 charge to install a kickout. So, and it's not brain surgery like most of this stuff is. Then you've got your grade termination. Improper, it's below grade. Now with an EIFS application, which is the topic we're on, your only exposure to that is termites, because they use that as a conduit to get past the pest control chemicals. Because the chemicals, just like water, can't penetrate the insulator board. So the termites will tunnel through the insulator board up to what they're looking for, which is the wet wood. Right? So, but what you'll get is folks will use a Centricon system, you know, bait systems as a means to get a termite warranty or bond. And that's okay. If the termite company is willing to take on the responsibility for that home, fine. Okay. But it shouldn't have been below ground, period, to begin with. And it's primarily from a pest issue. This is how it should look if it were done properly. It's cut up, the bottom edge is back wrapped and sealed, unlike a hard coat where it has a weep screed on the bottom. And EIFS, the barrier EIFS does not have a weep screed, so there's no need to have perforations. But they're supposed to back wrap it and seal it and finish it off. Again, so the termites don't have easy access. But the other thing it provides is the opportunity for the pest control inspector to see their tunnels coming up through the soil to try and get to it. You would hope he's looking at that. But at least it makes it more difficult for them to get to what they're trying to get to. This was from the second floor of a home that I cut out as one of my jobs. Okay? So imagine what the first floor looked like. But that's all the fact that it went below ground, it had all the moisture issues, you know, coming in at all the various places, so it was exactly what the termites wanted, and it made it easy for them to get there, and that's a cutout from the second floor of a home.
Question.
Yeah.
So when we see this as inspectors, what should be our recommendation?
Okay. We'll let Mike, what you should do is say, look, I don't do stucco, assuming you don't do stucco inspections, but you see some red flags, I suggest you have All American Home Services do a full stucco inspection, including moisture testing. Now that's self-serving, obviously, from my standpoint. But I'll be honest with you, I don't think there's anyone that does a better job than we do in the Atlanta area. And we're relatively moderately priced. So, but it's just like if you saw something with an HVAC system that concerned you, you'd say, get a licensed, qualified HVAC contractor to evaluate. Same concept, right? It's something that you don't do. Therefore, you try to send them to someone that you think will treat them properly. Is all you're trying to do. Same thing, and if you see fungal growth somewhere, and I've talked about this before to the group, don't say, that's just because the house has been sitting. You're looking to get your ass sued off by doing that. You put in there that you observe potential fungal growth on framing or whatever, suggest an indoor environmental professional do an assessment on the home. They may not do that, but that's fine. You've given them your best advice at that point. And again, I think a good indoor environmental professional is All American Home Services, obviously. But, but that's all you can do if you don't do those things, is try to refer them to someone that you trust and that you think will do the job properly. Yes?
Yeah, Bill, you may be going to get to this, but for the new guys, how do you tell the difference between hard coat and EIFS when you walk up to a house?
Good
What do you
question.
look for?
Yeah, there's two ways that you can tell pretty. If you walk up and you take the pad of your hand and you push on it gently, if it's hard coat, it's going to feel like you're pushing on your sidewalk. If it's synthetic, it's going to feel spongy when you do that. The other way is you take off an electrical outlet cover or a light fixture, and it'll reveal where they've cut out around the electrical box. And you'll see either metal lath with what looks like cement, which is the Portland cement, or you're going to see an insulator board with colored fiberglass mesh endings. Obviously, the insulator board with the fiberglass mesh and the softness is going to be EIFS. The hard surface and the metal lath and the Portland cement, which you're going to see, would be your hard coat. So I didn't teach that to realtors when I'm doing presentations about why they need that stucco inspections done, is when they're first thinking of taking on a house to list it, and they see it's stucco right away, they got to say, oh crap, you know, maybe we should have it inspected before we list it so it's clean when the home inspector shows up and he can't start talking negatively. And that's one way that I tell them that they can find out. Yeah, Joe?
Bill, you know, and there's the thump test as well. I mean, there's another method, as to the sound of the two types of
That's
surface
correct,
where
yeah.
they-
If you tap on it, the EIFS will be very hollow sounding, where a hard coat will sound like you're, you know, knocking on a driveway or a sidewalk or something like that. So 3 pretty easy generic ways to kind of differentiate what type you're dealing with. We talked about the grade issue before, right, where it goes below ground. You've got the same issue where it either is in contact with concrete pads or potentially behind them even. And what that does, it lets the termites come up from behind the stoop, because there's always going to be a gap, and then they got right up access right behind the insulator board. They've passed all the pest control, and they're up at the wood, which is what they're looking for. Yep.
You mentioned earlier about South Georgia, like Macon area, down in that area. They're still none of what you're saying are they doing down there. They're doing it like they did in 19.
No, but nobody did it here either, remember. These are pictures from real homes.
Just a month ago.
Yeah, they're not doing anything right. I have a client that, you know, they're fairly wealthy. They've hired us many times to do mold inspections on homes they were looking at or his commercial buildings he was going to buy. And he was having a $2 million home built off the Powers Ferry area of 285, right? So it happened to get water in, so he brought us out to do the mold assessment. But my inspector was there, he said, Bill, you're installing the freaking stucco wrong. And these are the guys that are building $2 million homes that don't know how to put the damn stucco on right. They're putting it on the same way they've been doing it for 20 or 30 years, which is wrong. That's what they would tell me in depositions. I've been doing this for 20 years. I said, good for you, you've been doing it wrong for 20 years. The instructions have all been there for you, but nobody reads it. So, but you're absolutely right. The difference is up here, a lot of builders at least are in tune with the code, right? That is banned. Down there, you know, it's like a Wild West show. Yes?
Back to hard coat and weep screens.
Yep.
Can you explain exactly how the water gets out? My concern is that it gets covered up with finished materials. I mean, should we actually see it weep? I mean,
The weep screen
what does
goes...
that look like exactly? What's the mechanics, and can it be blocked in some way?
Okay, I've got a picture here that's going to show you that when we get to it, and I'll explain to you. But the basic answer to your question is the felt paper or house wrap, you have the back flange of the weep screed that's attached to the substrate. The felt paper comes over the top of that, so you have your waterfall effect, right? So as the moisture runs down the felt paper, and then there's perforations all along the bottom edge of the weep screed. The weep screed is almost like a J channel of vinyl, except it has holes all in the bottom. So when the moisture reaches there from the felt paper, it gets out to the atmosphere through the holes.
Can and should we see that?
You should, yeah. First, if it's below ground, even if it's there, it's not functioning, right? So yeah, you should see it where the
Screen
stucco...
access, can we see it?
Yeah, I'm going to show you the picture when we get here, but even when you go out, if you see that the stucco is above ground, you can take your little mirror that you probably all carry with you, and just look at the bottom, and you'll see the holes all along the bottom of the metal casing. You'll see that it's there. But I'll show you the picture of when he's installing it. But this is what we thought. This is before is how it is generally at concrete pads where it's right in contact. This is how it should be. So again, there's an isolation of the system from the patio or stoop so that the termites can't come up behind it. Yep.
Is this EIFS?
Yep. Yeah, we're in the EIFS category now.
Okay, what about stucco and these kind of?
Hard coat stucco should also be 2 inches above the pad with the weep screening, right? So if you're not off contact, then having the weep screw doesn't do you any good, right? And it's all, this stuff's not rocket science, it's well, common sense. Yes?
Of course, the adhere masonry veneer is always installed in 32. But is it going to wake up as much as the stucco? Because they always put it.
You mean brick, you mean?
No, I'm talking about your synthetic, or your fake stone.
Oh, fake stone, yeah, see, and we'll get to that too, assuming I have time. But just getting back to what he's asking is that when we get in the stone category, the stone installation instructions are the same as hard coat stucco.
Correct.
Whether it's synthetic stone or what we call, there's a natural stone also that's cut thin and flat, but it's still real stone, versus your stacked stone or what we call full dimension stone, has the same installation requirements as brick. Okay? So once you understand the difference between the stone, which we'll get into hopefully, whether it's full dimension or stacked, or whether it's synthetic or flat cut natural stone, that has the same requirements as hard coat stucco. Your stacked stone has the same requirements as brick. For weep holes, all the rest of that, ties, all of that to hold it on. But again, it doesn't look bad when it's done properly, right? It actually almost gives the house an accent, the way it's done. It doesn't have to look like crap to be functioning properly. Decks. Now you all know about flashing decks, same routine, but how many times have you seen this? Where they put the cladding on before they put the deck up. So their idea of flashing was to put the flashing underneath and then run it up on the outside of the stucco. But even if you did that, if you were doing it yourself, do you think you'd at least seal the top of that? Just for the hell of it? No. It's just, there you go. The deck is flashed, right? But it's not flashed properly. The water's going to run right down the wall, right behind the flashing, and affect the perimeter bands of the house at the attachment bolts. May as well not even have it. And you see it all the time. Either there's no flashing, or they do this sort of routine. The good news is, in this case, the boards run parallel to the house. So the fix for that is a lot simpler, where they can just pop up that board, they could cut the stucco, put the flange in and re-stucco over it and finish it, you know, to make it work right. The tougher one is when they're perpendicular to the house. Then they got to take all the boards off to get at the ledger and do that. So that's a more costly effect. I think it's the next picture. I'll show you an acceptable alternative to taking all the boards off, okay, that we would accept if it were done right. And this is an after the fact type thing. It doesn't mean you do it that way to begin with, but now you're saying, okay, we've got all these issues. Money is obviously always an object. How can we deal with that at a way that's acceptable financially to accomplish it? This is where they'll actually put a true sealant bead with the backer rod and sealant at that junction of the stucco and the board to have the water run down onto the board and then fall harmlessly to the ground at the opening. But what does this create that would not occur if it were flashed properly? Maintenance. Okay? That's the trade-off the homeowner has to make. If you do this, now you have to do the thing you have not been doing as long as you've been in this house, which is maintain the damn thing, right? Now, when you notice that that sealant breaks loose over time, which it will, you're going to need to have that refreshed, or you're going to have the structural bands of your house rotted out over time. So that's the trade-off they make, is they say, well, for the difference in cost, I promise I'll maintain it. Right? Head flashing. You all know that that's required by code, correct? Do you see any there? No. It happens all the time. And you get it a lot where some of the windows are flashed, some aren't, where maybe they had a window installed after the fact, where they had a blank wall and they wanted it, or they had a window run out and they replaced it. Well, the window installer didn't put flashing in. Well, the homeowner doesn't know any better. And then you get all this wonderful stuff. Whoop. This is how it should look. Look at my corner. I got my fingers are all crossed up. Okay? So again, the water comes down, is directed off the top of the window or door. The other thing you notice is that the flange is slanted downward, correct? What happens if it's flat? Capillary action, where water will go flat and come back on itself under the flashing. So the front edge of head flashing, regardless of the cladding system, should have a downward tilt to it so that the water drips off onto the ground and doesn't run back on itself. If it's just a flat edge, the capillary action will occur.
What about, a lot of times you see synthetic stucco as an accent of a window?
Yeah.
Is that an approved flashing method? or is that-
You still look for there should still be the edge of flashing, and in the case of EIFS, it's called a drip edge. It's not truly flashing, but the concept's the same, is that, remember, the accents that you see many times are just glued onto the face of the stucco, particularly when they're on a hard coat system. These accents tend to be synthetic, and the hard coat wall is there, and they just glue them on, which means over time, moisture can get behind them. So then if there's no flashing or drip edge at the bottom, when it gets there, it's going in versus, coming out. But, yeah, you see that a lot, particularly on the front of homes. They'll do the accents, not so much on the sides or rear, but primarily on the front.
Bill,
Yes?
question. Can you settle this regarding head flashing?
Yeah.
And over the years, I've gotten into arguments with builders, with remodeling companies, etc.
Sure.
The purpose of flashing is to collect the moisture in the wall directly to the exterior.
Or act as a drip edge so that when water runs down the exterior side of the wall, it falls harmlessly off the face of the window rather than coming back in.
All right, so it's presuming water is behind the cladding and needs a way to get out, and that would be on top of the flashing.
Right.
So your left photo up there, if you seal the flashing with the sealant.
This is an EIFS application. Remember, moisture that gets behind an EIFS application isn't going to come down the wall like it will in a hard coat. Now, hard coat, you're absolutely correct. That's where it shouldn't be sealed at the top, so that the moisture, when it comes to the top of the flashing, gets out under the hard coat. Hard coat, you're correct, but EIFS, it's only acting as a drip edge. It's not acting as a true flashing, because moisture is not coming down behind the EIFS application. It's stuck in the wall. The only reason it reaches the flashing is because it's consumed all of the wall above. So by then, the flashing is the least of your worries. Yes?
I get into this argument with builders all the time. It's a self-flashing window.
Oh, Jesus. Okay. I had somebody dare to say that to me in a deposition. And if you read the code, okay, remember everybody, it's like numbers to accountants. You make a number to say whatever story you want, right? They read where it says, windows with a flange of 1 5/8 inch, I believe, does not require flashing, right? But it has to be, but it's only if it has that, not if it's just a, quote, where there's a nail flange, okay? That's not self-flashing. Self-flashing vinyl or aluminum windows actually have a drip edge built into them at the top, and they have weak channels in the sill with perforations, generally 2 to 3 holes along the face of the sill. So there's a little chamber there that the water that would normally get in at the junctions of the windows we talked about, get into that chamber, and then they come out the front of the sill where the holes are to let that moisture out the atmosphere so it doesn't get to the frame below. That's a self-flashing window, not a window that just happens to have a nail flange on it. And I won that case. So that's your answer, is that it has a real self-flashing window has a drip edge as part of it at the top.
Where can you find that in?
Well, it's in the, I can't remember the section now, but if you look at it relative to the windows and all, whatever section that's in.
It says all windows can be flat.
That's right. And then there's an exception.
Manufactured, one, spec.
That's right.
They're saying, well, the specs say you don't need it.
That is, when you go to the exceptions in that section, it'll talk about what has to be the rest of the window construction to qualify as that.
When we went through that window manufacturers, we specifically asked them that question and they didn't answer.
Yeah, okay. Remember, they usually are somewhere sitting on the table at a deposition, so they're not going to say anything that someone's going to pull out of a briefcase, which is what I do in a deposition. I get the builder, guy in Montgomery was the builder, he was also the president of the Montgomery Area Home Builders Association. He had decided I didn't know what I was talking about. So we went down and he said, his attorney said, why do you think this stuff's installed wrong? I said, and I pulled out the specifications from the manufacturer that he said he used as to how that was to be installed. I said, let me know If you see any of these details in that system, deposition lasted 30 minutes. Okay. That's it. Okay, no need to answer any more questions. I don't want to be too negative, but over a while, when you only see bad things, you kind of get jaded. You know, no one ever calls me to tell me how great things are going. There's always a problem that we're brought out on. And a lot of the builders have the same book of BS answers to your questions. They all are going through and say, oh, there's the answer for that. And it's all the same stuff. So, but back to your thing, that's sealed because this is an EIFS application. So therefore it's serving as a drip edge. It's not serving as a head flash. This is where we talked about where there's no sill pan flashing. You would actually see flashing that would look just like head flashing coming out from underneath the windowsill with a downward tilt, and it would be sitting in essence, a tray is what it would be sitting in with edges, so that any water that gets in at the junctions of the window are diverted out to the front of the sill, and then they fall out onto the ground. You'll never see that in your lifetime. Just as you talk about weed screed, you're going to see one or two in your lifetime. You will see 0 sill pan flashings in your life. And the same thing comes back to when you're doing your pre-drywall inspections. You note how the corners of those window openings are done. You're going to see all raw wood where they did the slit to go around that corner. And that's exactly where the water's going to get in.
What's wrong with these? I'm sorry.
Well, there's no sill pan flashing at the sill of the window. Okay? The other part is what happens in real life is the joints of the window open up. See all this? So that's why the sill pan is there, because that's going to happen over time and water gets in at those joints. That's why a lot of times when you're looking at rotted windows, you'll see it beginning around those joints of the jamb and sill, because that's where they open up. Moisture has its first opportunity to start to affect it. The other place that it'll happen is at the sill nose. Many of these windows are a 2-piece sill nose where they can pop the front one off. But obviously that creates a joint that is capable of opening up. That's the whole purpose for sill pan, but in lieu of that, like when we write our scope of work, we realize they're not going to take all the windows out of the house and put a sill pan in. So then put one line in our scope of work on each elevation is to properly seal all the construction joints and miter joints of the window. And that becomes a maintenance issue, but you have that, or you can remove all your windows in the house, put a sill pan in and reinstall them, which will have a few zeros involved.
You're not saying we need to be calling this out if you don't see the sill pan flash.
Well, but if you see, because you'll never see it, you could probably put that as a line in your report. But when you see the joints are opened up, that's a call out. Say that that's an opportunity for moisture to affect the framing beneath the window. That's the real world of what you're going to see there. This is how it should look when it's done right. And these, not that there's a sill pan, but the accent is sloped. I kind of got ahead of myself a little bit. Any horizontal surface should have a 6/12 slope to it, which is 22.5 degrees. And that is so debris and water can't collect on that surface. And then when the sealant at the base of the windowsill begins to break down, it gains access. The whole concept, just like flashing that's tilted, is to let the water and debris wash off and fall harmlessly to the soil. That's how it should look. You'll find flat surfaces everywhere. So here's more pictures of the joints opening up, right? See that? That's what happened. That's what's going to happen at the windows over the lifetime. That's why the sill pan was supposed to be there, but in lieu of it being there, you've got to say those things need to be sealed and maintained to prevent moisture from affecting the wall area under these windows. Okay? And here's where they're sealed properly. Okay? And part of it is what they actually have to do is they raise the lower sash, and they actually take the track and they pull it out and they seal behind the sash. And then they put the track back in, and then the rest of the exterior part is sealed. The reason being, if they just seal the track on the outside, and any moisture gets behind the track, now it's trapped in there, isn't it? So that's why they have to pull the track out enough to get the point of the caulk gun in there and seal that seam, put it back in, and then caulk the rest of the joint. So it's not like it's nothing to do, but it beats the hell out of taking the window out. Did you have a question? A little bit of damage. Birds love this stuff. They use the mesh and the insulator board for nesting material. You can see how thin the coating is. They peck right through it. You know, you see it on chimneys all the time. You know, in this case, the corner under a soffit or a freeze board or something.
Proper fix for that.
You just got to come out and they got to refinish it and somehow try to blend it in. Yeah, they'll cut it out, patch it. They'll try to blend in the finish, try to figure out what system it is where they'll get the same aggregate pattern. You know, but you're going to see it. Okay. The other thing, one thing they can do with paint is try to paint, if they can find a boundary, they'll get paint mixed to match the weathered color, so that then they'll paint to a boundary so you don't notice the joint so much between the old and the new. But that's more of an aesthetic issue, you know, that you understand with folks, but the main thing is to stop it from letting moisture behind it. This is what happens, again, you see the breaking of the system at the bottom. This might be just as good as a weep screed, you think? So yeah, there's a weep screed for you, but not likely. But you get that stuff, you get this here, whoops, sorry, where moisture has affected, whoops, I need somebody to hold this clicker for me. Where moisture has affected the ability for that stucco to adhere to the substrate. So it begins to come off. That's called delamination, where it actually starts to come off the wall because it's losing its adhesion. Sometimes it's because there's insulator board on a hard coat and it can't stand up to the weight or the movement that's going on for other reasons. Here's some rot that only just began last weekend. Same thing, here's your structural bands as viewed from a crawl space where maybe a deck has been attached. More good stuff here. Here's a little bit of rot, just occurred the other day. We tend to put something like, Charles has a great technique, he always has a pointer that has like a colored tip, so like many times in a picture there could be any number of issues. You know, the guys will use a pointer that will draw the eye to the exact problem that you're trying to talk about. So it's a great technique, it helps the layperson reading the report understand, okay, what of the 5 different things that are in this picture are you actually talking about? Hard coat specific. Now remember, all the things, sealants, flashings, kickouts, all that stuff are whether it's EIFS or hard coat, right? All the same stuff. The things that are specific to a hard coat is what we actually talked about in the beginning. Control joints are required horizontally at each floor line to pick up the cross-grain shrinkage that occurs in new construction. And then you've got vertically at every window and door. No wall area greater than 144 square feet. The consequences of not being installed is cracking, too few or no control joints. Okay, this is where there are no control joints in this thing. Okay? This it does, okay, and it's kind of faint in the one on the right, but the panel is broken up. There's vertical joints, horizontal, where they've taken this large wall area and broken it up into panels, in effect, just like a driveway would be. And then obviously they've got the control joint here. This is an EIFS expansion joint at a floor line. The expansion joint is actually where the panels, there's a space between them, and they fill that with backer rod and sealant, again, to pick up that cross-grain shrinkage that occurs. When they don't do that, that's where you'll tend to get bulging, where you'll see bulges in an EIFS application, primarily in the area of floor lines. Because the house shrank, but the EIFS had nowhere to go, so it just starts pushing off the wall. Same thing happens where it goes from framing to foundation. You've got a change of substrate. They're going to move at different rates, right? Same concept. Those are the 2 locations where you'll tend to see bulging in an EIFS application because of that effect.
Should we call out this control joint even if we're not seeing symptoms of a problem?
No, again, it depends on the age of the house. This is the common sense thing. If it's a 15-year-old house, it doesn't have control joints, but there's no real failure, then it really is designed for the first 2 to 3 years of a home when it goes through all its movement. That's what those features are for. If it's gotten past that for 15 years or 10 years, then it's really not an issue, no different than any other thing you might see that's not failing. But maybe it wasn't done thoroughly correctly, but not failing this way, not really much of a need to do much about it. So you're always applying a little bit of common sense to the technical requirements, just as you do every other day. Here's the cracks we talked about. Where do they occur? You guys will see this every day, right? There's no control joint at the corners of those penetrations, and that's where the stresses of the system will focus. And if there's nothing there to break in an organized manner, it'll make its own break. And it always is in that case.
That control joint coming off an opening like that only has to be vertical.
Well, it's vertical because there's supposed to be a weep screed at the bottom, which is a control joint in itself, that's horizontal. And there's a horizontal control joint at the next floor line. So the vertical control joint would come from here and go down to meet the weep screed in this case. Or if this were a second floor, it would be coming down from here to meet a horizontal control joint. They've always got to intersect with each other, so that all that transfer is spread out over a wider area. Here's a weep screed or no weep screed, where the termite guys came in, said, okay, we got to cut that system up above ground to get your termite bond. But they have no idea what the requirements are for stucco, right? So they cut it up and they put, it sounded like kind of a finish coat on there. But there's no weep screed, just as there wasn't one before they cut it up. So it's not functioning. It works great for the termite company, but they still haven't addressed the problem. That's why I always put it in my scopes for the stucco contractor that knows what we want done, when if it's required to be cut up above grade by the termite company, that they incorporate the weep screed at that time. Okay. Who was it that asked about the weep screed before, what it looks like? Here you go. Now, I'm going to ask you a question at the end of this. Here's your weep screed being installed, right? There's your holes in the bottom of it. What happens is your felt paper or house wrap comes over the top of the flange, and then when the moisture hits here, it gets out at all those evenly spaced holes in the bottom of the weep screed. And it's the same as a casing bead, in effect. It's a galvanized aluminum thing. But who can tell me what's wrong with this picture? Very good. He gets an A for effort. The guy's even bothering to put a weep screed in, but he's not putting it in right because it has to be greater than 4 inches from soil, and it has to be no greater than 1 inch from the sill plate, right? So in effect, this thing's not going to work because when they apply that Portland cement to the foundation, it's going to basically take away the air pockets that you would normally expect to find above where there's wood framing and kind of spacing. So it may not ever reach the weep screed. But good catch. That means you're paying attention. That's good. I don't have any candy here. Here we go. Freeze boards, no sealant. This seems like petty stuff, but you'll get wind-blown rain if it's not a large overhang. That'll gain penetration at the freeze board intersection and start working its way down. If you remember that picture 2 or 3 frames back where it was cracking up on an upper level, that's what happens when the water's getting in above it and it starts to damage the substrate that it's attached to and it starts to come off the wall.
The staining now?
The staining, that's an efflorescence issue. And let me get back to there. You'll see this a lot on chimneys. And what it is moisture. There's usually not a kick out up above where the roof meets the side of the chimney. This is reflective of the moisture that's gotten behind the stucco on the chimney and is working its way down. And the efflorescence, as you know, is the moisture coming through a masonry material that gives off that, usually a salty looking substance, but it can also be in the form of mildew.
But how do we know that's not just surface runoff from the roof line?
Well, the way you do is if you're doing an inspection, we're going to probe. Well, first off, we're going to go up and see if there's a kick out. But we always, when we do ours, we always probe under kick out locations whether they're there or not. Because typically the kick out was not there at installation. It's something that may have been retrofitted. And we find that in probably half the cases they're installed wrong. The guy, remember the mentality, I'm up 25 feet. Nobody's going to see what I'm doing. I just make sure there's something sticking out enough that somebody sees that there's a piece of metal there, right? And they may have glued it onto the side of the stucco, which, Charles, how many times do we find that? That the kickout is just adhered to the outside of the stucco up on the roof. But you see the face of the kickout, you know, from the ground, right? But when you go up there and look, or they don't put it underneath the flashing, it's just under the shingles. So when the water comes down, it gets right underneath the bottom part of the kickout and gets right in behind the wall. It's always too much trouble to do this stuff.
Hey, Bill, that
Yeah.
chimney staining you see is very critical to tell you something's going on, because I remember doing an inspection for you
This may
and
have been
saw
one of your
that,
pictures, frankly.
and got really high moisture readings under that where there was no kick out at the roof line. And when I went to puncture to do my moisture test, every bit of the framing within that chimney chase fell down onto the top of the insert.
Okay.
It sounded like the house was caving in.
Yeah. That's why we always probe those locations, because before that kickout was retrofitted, there's no telling how much damage structurally was done to that house. So when we probe, we're not only looking to see the moisture content, we're also feeling the condition of the structural materials.
So if we see staining below a penetration point, obviously it looks like a problem.
Particularly on hard coat, you'll see that because it's a cementitious material. That's like efflorescence concept. Moisture is coming through it. And it's coming through it because moisture is getting behind it. Okay.
So a staining like this, what we're talking about in your situation is where the roof line ties into the chimney chase, not up where the shroud's attached on top of the chimney.
No, it's right at the roof line and the chimney.
Where the roof line meets the side of the chimney, there should be a kick out there. And generally, when you're seeing this, there isn't one or it's improperly installed. But also, it may have only been installed, let's say, a year ago, and it's a 12-year-old house. That means there were 11 years of water pumping into that chimney chase. And to Mike's point, the whole friggin' thing is rotted behind. The only thing holding up is the stucco itself.
No, but I think your question is good, because we see a lot of staining along the top part of the chimney chase a lot of times.
Mhm.
Is that indicative of a potential problem with the cap or something?
That's right. It could be, depending on if it's above the roof line, then you got to see that the cap actually covers the entire top of the chimney, that it doesn't just sit on the edges, because then water can get in. It has to cover the entire stucco, similar to a drip edge concept, right? But sometimes they only just sit on the top and then there's a band, well, the moisture gains access. So if you're seeing it above the roof line, it's generally the chimney cap. Below the roof line is probably a kick out or termination type thing.
Do you use an infrared camera when you inspect? If so,
No.
can you give us some tips on it?
Okay. My thing on infrared cameras is they're excellent for certain applications. Pest control, energy audits. However, they are not indicative of moisture in and of themselves. We always probe with a Delmhorst or equivalent meter with 6-inch probes, where we will, if it's hard coat, we actually drill 2 little snake bite holes through the cladding to reach the substrate so we can not only test the moisture but feel the condition. Infrared, from my standpoint, can be affected, and tell me if I'm wrong, there has to be, I believe, at least a 15-degree difference between the outside and inside temperature for it to be a valid test. Is that correct?
That's true, but it also gives you, most of the infrared guys are gonna get a general picture with the camera and then go with the probe after.
Yeah, I don't believe in them because I think, this is my opinion, okay, that they're oversold in that they're no different than a Trimex wet wall detector. Do you know what that is? Okay. Does everybody know? Trimex wet wall detector, when you're doing EIFS inspections, is a surface moisture meter that sends a signal into the wall, either 1 inch or 3 inches deep, and the way it comes back to the meter tells it there's a possibility that there's moisture there. However, if there's a piece of flashing or a nail head, it can give you a false positive. The only way to validate it is to probe and test with an actual pin meter. Okay. To me, the infrared camera is no different than a Trimex wet wall detector in that you've still got to probe to know if it's an accurate reflection or if it's a false positive. Okay? So we use Trimex wet wall detectors on EIFS applications. That's the only application it's valid for. But I'm not a fan of the infrareds as an end-all that, yes, there's moisture. All it is at best a relative possibility, and then you still have to prove that by probing it, you know, and getting an actual percentage. Yes, Charles?
And I use infrared for my own stuff, so I understand infrared. But for this type of application, you want that up close and personal evaluation. You don't want to be looking at it with an infrared camera and say, oh, there may be moisture behind there, and then go probing. You want to be up close and personal. You want to look at the joints. You want to be able to see that, because you may not have enough of a difference from an infrared. And so if you just did it with an infrared, you'd sit there and say, oh, there's no reason to take a close look. But in reality, there is, because we haven't had any rain in 2 weeks, and you've got a gap up there that's going to allow moisture in there that you would never see with an infrared. So in this case, you know, you really need that up close and personal view of things to properly evaluate it. And then if you see something, you know, you want to do your moisture probing anyway. So in this particular application, infrared doesn't aid in the process, it just slows it down.
Another thing, coming back to the infrared, is what happens is when wood substances get so rotted from water, they actually won't hold moisture anymore. The water passes through them. That was like to Mike's case, where he probed it and the whole inside fell down into the chimney chase. Because it was so rotted, you're not getting any elevated moisture when you're doing your reading, whether it be a Tramex or an infrared. Okay, so you can get a false sense of confidence if you're not putting your hands on the house and probing it in the locations that you know are opportunities for damage. Right? That's what you have to probe it in those cases. Yes?
You know what I do is I pound underneath the roof wall joints, and you can hear the crumbling OSB and substrate. And I do that first before I even probe, just because.
But I've had things where it didn't necessarily fall in, but when we probed it, we went right up to the handle on the probe. But you'll get no elevated moisture reading, but you're up to the handle. Because everything's so rotted, the water's just passing through. It's not hanging on to it to give you a suspicion that there's a problem. So for me, you know, I'm just old-fashioned. You're going to put your hands on it. You're going to understand what's wrong with the installation, where the opportunities are for moisture. And in certain places, you're going in. And you're going to say there's X amount of moisture by percentage, and the structural materials are either still firm or soft or not there at all. And that tells you what's going on to your client, because when I write a scope of work, if we get the situation where everything falls in the chimney chase, we're going to have in the scope of work, they're going to remove the stucco off that chimney, fix the framing, reinstall the stucco the proper way. We can't tell them to do that if we don't know that answer. Yeah.
I can change the context of the conversation a little bit, but I think we're probably going to run out of time here shortly.
Yeah.
If you're looking at synthetic stone application to the front, in the places where you commonly see you see stucco.
Yeah.
If you come across to the corners or the edges of the stone and be able to see felt paper, or you can come in between the joints and be able to see felt paper or anything between.
There'll be metal lath.
Would you say that it's installed incorrectly?
Yeah. Yeah. And I'll get to it very quickly because we're probably pretty close. And I'll try to get it in I'll move up to the stone.
Because you see that a lot, I mean, and then they don't come through, they don't seal, they're not sealing around the stone, they come through and put their vapor barrier backing on it, but they're not caulking or sealing where the felt paper is going against the windows or anything.
But here's your basic answer. If you had stucco meeting brick, you would expect to see a sealant joint there, would you not? Where the two dissimilar materials meet, that's the basic word. You have two dissimilar materials meeting, they're going to move at different rates, therefore they have to have a sealant joint to prevent moisture from entering. It's no different than if it's stone, stucco, composition siding, vinyl siding, doesn't matter. You've got to seal those junctions to prevent moisture from affecting the house. But in stone, we have two categories. We have adhered stone, which is your manufactured synthetic stone, and you can find all those specifications on mvma.com, which is the Masonry Veneer Manufacturers Association. There's all the schematics of how every detail is to be done. But if you just think of it that you inspect the synthetic stone or the flat cut natural stone as if it's hard coat stucco, and you take the stacked stone or what we call full dimension stone as brick, that's what you're looking for as far as terminations. The synthetic stone requires leaf screeds, sealants, head flashings 2 inches off contact with concrete, off contact with soil, the whole shooting match, okay? It's exactly the same.
I've looked up the installation instructions from these associations. They say the weave screed is optional.
No. Depends on which stone you're looking at. The weep screed, if you're doing a stacked stone or full dimension, it's weep holes, just like brick would be. And you have your same through wall flashing, etc. But the weep screed is required in all the stone applications. But we do all this for corporations, and it's absolutely required.
That's what I'm looking at.
Yeah.
I see in the construction, they're not putting weave screeds on a lot of stuff.
That's right. And the same thing's happening as if they did hard coat stucco. If it gets behind it, there's a felt paper just like there would be the hard coat, there's metal lath, right? The moisture gets down to the termination, it can't get out. And who did the stone the other day? I don't know if it was you, Charles, or Eric?
Probably Eric.
It had to be Eric. But it was a stone application where it didn't have the weep screed, it was on the concrete, and all the structural band under the front door was all rotted out. Because the moisture is gaining access at that location. Yes?
In most, if you explain, in the application of stone, whether it's synthetic or natural stone, that's just really going to be adhered. The backing behind it is more like the stucco, which is the actual.
It's a mortar, you know, that the stone is stuck into.
But I mean, it's almost so. If you looked at it from an application standpoint, the weather barrier or the substrate for the stone is actually like the stucco veneer. It's like a stucco veneer, and then you're just sticking the stone to it, right?
Yeah. But see, here's the specifications from that document. Okay. This is installation over wood framing, and there's your weep screed. Okay.
Bill, what was the website that you just mentioned?
mvma.com or org, one of the two. And that's the Masonry Veneer Manufacturers Association.
Okay, guys, we're going to have to cut it off here. One last question for Bill, and then we got to.
I'll take it. I'll take it.
Okay, Russell.
On cultured stone, in your practice, how many problems have you seen compared to the stucco? I mean, can you give us an idea of magnitude?
We do stone almost every day for corporations, okay, corporate relocation companies. They send us to Tennessee, Alabama, South Carolina, and Georgia because of what we do. Every one of them is installed improperly, just as every stucco job is installed improperly. Then it becomes just like with stucco, okay, what's happening as a result of that? How lucky are you? Like I just said, we did the stone job, the whole structural band under the front door area, where the front door, the thing with stone though is it tends to be on a limited area of the house, it's not the whole house. So it does limit your opportunities. But in this case, it was around the front door area. And the whole damn structural band was rotted out, and all that stone's coming off. They got to pull the sheeting out, fix all the framing, and then reinstall whatever they're going to do. Every one is installed improperly, just as all the stuccos are installed improperly. It's the same mentality, it's the same people, okay? And many times in depositions, the applicator will be talking to me outside, and he'll say, oh, we know what to do, because remember, they have to be certified by the manufacturer to buy the materials, right? They've been through training. They said, but the builder won't pay me enough to put it on right, so I have to leave things out to make a profit. The consumer ends up with the result of that. And then you're coming in to inspect it, you're the bad guy, because you're telling me did it wrong.
Okay, good stuff, guys. We got to cut it off there. These are the two guys. We got anything having to do with stucco, exterior wall cladding, mold, mildew. Bill's your go-to guy. See him after the meeting. He'll be able to help you with that. We want to keep moving here. Again, we have an action-packed meeting for you today. Stick tight. We're going to have a break for you here in just a minute, but we want to have our friends at the Georgia Department of Community Affairs come up. Ted Miltiades is going to come speak to us. Bill, is that you that I see there? Bill Townsend? We have the pleasure of having occasionally direct contact with the Georgia Department of Community Affairs. These, as you know, GAHI being, wanting excellence in contacts and things that we do. Georgia DCA comes to us and gives us code updates occasionally. So I'll turn it over to Ted, and he'll give you the latest information about Georgia codes.
Thank you. Good morning. Good to see y'all since y'all's conference back in March. See y'all in at Emory Center. We wanted to come today and just take about 10 minutes to update you on some things that are going on at DCA. Primarily, we did finish the electrical code, so the new electrical code 2017 edition will go into effect January 1, 2018. So that will be one of the things that you'll be looking at and inspecting for. The other thing that I talked about a lot last time I was with you was the energy code. We are still in the review process for that. We have not completed it. It's been a lot more work than we thought. You know, the energy code can be a bit difficult. So we are still reviewing the 2015 IECC. We have a committee of 17 that's been working very hard. We have one more meeting, and that meeting is going to be next week, next Thursday. And we hope that will be the last meeting of the task force, and then it will move up the line to the State Codes Advisory Committee. We do anticipate a lot of code amendments. It's going to be a pretty big packet with a lot of helpful things in there that help you with the inspection process and what to look for with the energy code. So we are on target, but the energy code date has been moved up, and this is very important because I think I said 2018 when I was with you. I'm sure I did. So the date is January 1, 2019. We plan to finish the work this year, this fall, or early 2018, but we want to have almost a year of a final finished product for you to look at, and we want to try to have training around the state, and we're trying to get a grant to provide training for builders, home inspectors, city and county inspectors. So that's the big thing to remember. The energy code, new energy code will be January 1, 2019, if everything goes accordingly. We don't anticipate any delay in that date, but we do anticipate maybe a few more changes that we'll have to go through before we get there. So the final product, if you want to see what we're doing, you can go on the website and you can see all the amendments that have been passed so far to go along with the code addition. So electrical code, energy code, two very important things. Then we're going to start also late this year and throughout 2018 and 2019, we're going to be reviewing all the other codes. Residential, which you're primarily concerned with, the building code, plumbing, mechanical, fuel, gas, and then we'll also take the fire code as a state fire marshal reviews and adopted. So those other 6 mandatory codes, we're going to begin the review process to go with the swimming pool code that, we made that mandatory January 1, 2017. Just told you about the electric code, and I just told you about the energy code. So that's 3, and then the other 6, and the one that you're primarily concerned with is the residential code. So I'm going to be sending a letter to your President Mike Parkman over there and asking him for a nomination for someone from your group to sit on that task force, along with the home builders and a building official and some other folks to review the 2018 IRC. Then we're going to review all those other codes and have them all go into effect on the same day, January 1, 2020. So I know that seems like it's a long ways off, but it's just a little over 2 years. It's going to take some time to review all of those codes, to make any state amendments, which, as you know, all of the codes have state amendments except one. And what was that one? There you go. And I wish it would be good if we didn't have a lot to all the others, but it's also a good process that we can amend the code in Georgia and change it accordingly how we want. So we'll be sending you a letter. Give about a month to find somebody that's, and y'all are all knowledgeable on the codes, that is knowledgeable about the RRC and willing to commit till about 5 meetings. We'll probably keep you all day. We'll feed you, but we want to go through that code thoroughly and make any amendments and want your participation in that. And then, as I said, January we'll have training. Our goal is to have some training on those codes too. And then January 1, 2020, we'll update. Those 6 will go into effect to go along with the 3 I just mentioned. So that, remember, there's 9 mandatory codes in Georgia. Then we'll worry about those optional codes a little later. So the main things I want to get across today: new electrical code, January 1, 2018. Energy's been delayed for a year to January 1, 2019. And then all the others we're going to be working on and have them go into effect January 1, 2020. So I know I said in my speaking around the state, we thought the energy code would go into effect this year, but it's not ready. The other thing we're here to do, along with the energy code, is we passed out, I think did everybody get a survey on the energy code? And we're trying, this is going to help us, if you could take a few minutes this morning and then we'll hang around and want to collect those surveys on the energy code and where, what you do with the energy code. If you can answer those questions, we're doing this with all the groups, the home builders, the building officials, heat and air folks, answering these questions on the energy code. And then we're compiling all that information so we can find the resources to better serve you and have any training that needs to be curtailed towards you. I'm glad to answer any questions. Bill can answer any questions I can't answer. I'm going to look at my list. If anybody got anything right now, I think we only have a few minutes. Yes, sir.
It's not actually the law, right?
What, say that again?
The deck,
Oh, the deck manual.
Yeah.
That's something that you can choose and utilize.
yes, but it's not the law, right?
It can be used to comply with the law. You can use the code book or you can use the deck manual. Because and I think you're asking that because some people are saying you have to use that. Is that coming from there?
We would prefer that we use
Don't
that.
have to use that. I referenced that and they said, well, it's not, it's only
It's an option.
option.
Yeah.
It's not the law.
Right, it's an option. They can choose to use that. Correct, Bill? Bill, come on up if you want.
They can use either one. It's up to the code user which one they want to use. But it is adopted into law as an option. So it is adopted with the laws into law, but it's not the law of the land. Unless the local government wants to make a local engineer
Yeah, what, do y'all feel that should be mandatory in just that?
Yeah, no one's
That's
gonna use the more
something that
expensive option.
Your representative needs to convey when they get on that task force and say, hey, we feel strongly that the deck manual should be the only thing used for decks. So, and then if you can persuade the other folks on there, that might become the law. But that's good, that's something, that's kind of input we want, that's what we want your participant to do. Yes, sir.
This is a question I don't know. Is there any type of reporting process or, I guess what I'm saying, in rural areas where there is not a good code enforcement or inspection department out there, is there any, what does DCA do, or is there anything that DCA does if they were to identify builders that are just building the way that they want to do it without any compliance to the state mandatory code?
Unfortunately, DCA doesn't have field authority or interpretation authority, so we can't go out there and tell that builder you didn't do it right in the absence of a code official, you know, this is the way it should be done. Your only other avenue would be probably the Governor's Office of Consumer Affairs or the licensing board, because of course all the builders have to be licensed. And, you know, in some areas they probably don't even have permits. But that should be a small, very small area of the state that does not have
So I mean,
that.
if the state has a mandatory building code, minimum building code.
Correct.
And there's builders out there that are not complying with that, because you can clearly identify it from their policies that they're implementing, in the way that they traditionally build. Who enforces that, the mandatory minimum code on these people?
The law states that the builder or the plumber or the electrician, whoever is the licensed professional, is responsible and required to build a code. If they don't, your only recourse in those areas, which should not be a lot of areas that don't have a building inspection department, is to go to the licensing board and file a complaint against that builder. Yes, sir.
Bill, with the response to the deck code, what we typically do is we tell them they have to build to the deck code unless they can prove to us that they're building it to a specific part of the residential code.
You tell them they have to what?
They have to actually build to the deck code. If they're not going to, then they have to tell me specifically which part of the residential code you're using.
That's exciting.
So I'll put the onus on them.
I don't have a problem with that. I think that's a good idea. I mean, yeah, I think that they need to build one or the other and to be sure it's code compliant. And there's no reason they shouldn't have to, if they're the builder, they need to show you what code they're using. I think that's good. Yes, sir.
Doesn't it say that either an engineer or an architect, if it's designed, they don't have to build it to the prescribed date?
If they want to use an architect or engineer, that's fine. When it falls out of the parameters of the code or the deck manual, then you would have to have one in mind.
Well, on the cover of it, it says right here, a copy of the deck detail must be on the job site. It doesn't say it's an option. I'll put it right there, it says it's gotta be on the job site and build a deck.
Where are you reading that at?
Reading that on your.
But that's the prescriptive code. That's the prescriptive code, so. Yeah, if you're using that as an
If
option.
you're using it, I think it means it has to be on the job site, but if you're not using it,
It says you can use either in the code, though.
yeah. That's a good question now, because that question comes up a lot about which one can we use.
Are you reading from the DCA 6 document or the Georgia Department of Community Affairs?
Georgia Amendment 50.
Okay.
All right, if you're using it, then you need to have it with you, yeah.
Bill,
But if you're not using it,
Bill, what that's all about is if they don't have the prescriptive deck code, then they have to have an engineer drawing. And the prescriptive deck code takes the place of an engineer drawing if they're gonna adhere to it.
all right. You good, I'm good with that.
All right.
Any more questions? Y'all are a good group. Yes.
You know, we're the only people out there that are responsible when they fall off the house. And so, I would, well, us as the builder, I mean, the builder's guy on the job site argues with you, he has no skin in the game. The county has no skin in the game. The only person that ever gets sued is the home inspector. And so I say it's gotta be here for an engineer drawing, because this is two things. So am I wrong about that?
It's an option. You can use the code or you can use the deck manual. And I have to leave it at that.
The way I interpret that deck code is it's all in the IRC anyway. Is that correct?
No.
It's a little more prescriptive and stringent than the code in some regards. For example, it requires posted post columns, and you could use less than that in the code. So there's some things in there that are more stringent because of the fact that it's prescriptive and written. But it's not, it doesn't cover everything, obviously, but it covers the basics.
Let me ask you, any of y'all inspect tiny houses? Has anybody been called upon to do that? Because, that's a whole growing field now, and we are, one of the things that's also going to go into effect the first of the year is a tiny house appendix, which is going to allow folks to build tiny houses and maybe code compliant. So that may be a whole new area. There's going to be a Decatur Tiny House Festival, and I'm not promoting it, but I have to speak there. And last year, there were 600 people there interested in tiny houses. So it is a whole new field and a whole new area. So one of the things we tried to do was to be sure that those homes were code compliant. So we changed the code and changed the room size and did some other things to make it easier for folks, to give them another option if they want to do a tiny house. And if the zoning laws in the community are changed to allow a tiny house park. Yes, sir. Wheels do not fall under our program, no. Just those put on a permanent foundation. There's some other law or something that falls under, it doesn't fall under this state agency. Do you have more questions? Sir?
Container house?
Shipping containers? We're still looking into that. That is on our agenda to try to bring it into our industrialized buildings program, and that meeting is December 7th. So if you want a couple of meetings, if you want to know what's going on and see how things run at DCA, December 7th is the industrialized buildings program meeting where we're looking to bring shipping containers into our program. And the next State Codes Advisory Committee meeting will be November 16th, and that's where we're going to hear the final report on the energy code. So there's a couple of important meetings. I think I've covered everything I wanted to come here for. So we'll be around a little bit. But please fill out that survey and give it to us. Thank you.